The very last item that I want to discuss in this topic, in this competency, and in this class is navigation. Now, most of you already know how to navigate. You zoom, pan, rotate, or tilt a scene. And there's different types of navigation in ArcGIS Pro, including 2D map views and 3D local and global scenes. And you can see those in the image on the right, in which I have a 2D map view that I can zoom, pan, or rotate, and a 3D global scene that I can zoom, pan, rotate, and tilt to add perspective to my scene. Local and global scenes also include the ability to have planar constrained navigation or first person walking. Planar constrained is where you constrain the navigation to a single plane, for example, a horizontal plane, so that you can move forward and back without losing height or gaining height, or a vertical plane where you can only go up and down in the vertical plane. First person walking navigation simulates a person walking at ground level. Now, there are different methods for navigating a scene, including camera, interface, linked, walk roam, and animation, and we'll discuss each of these. I want to start with camera because it's through the camera in which we view the scene or our world. And the camera represents the observer location and the target that the observer is looking at. In the scene below, you can see that the observer is standing on a building overlooking the baseball stadium and looking at the target, which is the pitcher on the pitcher's mound. And it's those two locations within my scene that define my camera. Now, you can interactively or explicitly set the camera. To explicitly set the camera, you go to the view ribbon and click on the navigation drop down, and you can click on camera, and that opens up the camera dialog where you can set the horizontal and vertical coordinates in the X, Y, and Z field, the up or down angle in the pitch, the rotation or direction in degrees in the roll or heading, and then last, the extent in degrees, which defines your field of view. So 180 would be like a fisheye lens, and 10 would be like looking through a little cardboard tube. In this case, we've got the field of view set to 55 degrees. Now I can enter those values explicitly in this dialog, and it will position my camera, or I can use the navigation tools available to me and interactively position the camera location. And so when you set a bookmark in a scene, you're really setting a camera location for that scene. There are a number of interfaces we can use in ArcGIS Pro to navigate a scene, including Explore button, the navigator control, the keyboard, and tasks. The Explore button, most of you are already familiar with it. Once you enable it, you can use the left mouse button to pan a scene, press down the wheel to rotate or tilt a scene, or the right mouse button to zoom in and out on a scene. You can also, in the drop down for the Explore button, enable planar navigation and first person navigation. If you enable the full navigator control, you can see you have the full range of motion to navigate a scene, including planar navigation and first person navigation. Sometimes it's easier to use the keyboard shortcuts. For example, I can click and hold down the V key to rotate a scene or the B key to look around a scene. And last, we can use task-based navigation. For example, zoom to layer or zoom to selection, or even use a bookmark to navigate to a specific camera view of your scene. Now, the best way to get familiar with all these different interfaces is to use them. And so play around with the Explore button, the navigator control, your keyboard, and even some of your task-based settings to see how you can use these different interfaces to efficiently navigate a scene. Most of you already know that in ArcGIS Pro, you can link two map views, but you can also link two scenes, or you can link a map view with a scene, and you can link it by centering both the map view and the scene on the same location, or centering and scale them. And you can see how it'd be really useful. For example, on the right, I have a scene that is looking at the baseball park. On the left, I have a linked map that is showing me the extent of what my scene is seeing. And so that's pretty cool because I can see where this 3D camera angle is by looking at the geographic context in 2D in my map view. And so as I interactively navigate a map or scene, the linked map or scene updates in real time as well. Another method for navigating a scene is to walk or roam around the scene. You can use the Explore tool or the Navigator control to enable first-person navigation to walk around a scene, so it simulates somebody at ground level at walking speed. You can also hold the Q on the keyboard and move the mouse around the scene to roam or fly through a scene. Now, walking and roaming around a scene are navigation methods that we often combine with animation to create and publish a 3D movie. Now, I'm not going to go through creating an animation with you. We actually do it in the lecture demonstration. But briefly, what you're doing is linking together a series of camera views and then exporting them out as a movie, an MPEG movie or an AVI movie that you can view in a standard viewer. And again, we'll demonstrate this in the lecture demonstration for this topic. And so 3D data analysis and visualization are no longer just a bell and whistle in GIS. We use them for all types of applications. And a common one that we're seeing these days is the development of digital twins, which are photorealistic 3D models of real-world objects, processes, and relationships. And we can use digital twins to answer questions like, how will the proposed skyscraper impact the city skyline? What does the wireless network and signal coverage look like? And what did the historical building interior exterior look like before the fire? And matter of fact, when Notre Dame Cathedral burned down in 2019, they went back to some digital twin data that were created by a US college professor to help rebuild Notre Dame. So again, we can use the analytical process, question, inform, analyze, decide, and present to develop a digital twin where we first define our question, purpose, or story. Then we collect and assimilate the 2D and 3D data required to inform that question, purpose, or story. Then we create and analyze our scene, evaluate and refine our results, and last, we configure and present our visualizations. All right, so by the end of this topic, you should be able to describe the advantages of 3D visualization, including vertical information, intuitive symbology, unique perspectives, real-world navigation, and enhanced understanding. You should be able to differentiate between global and local scenes. Global scenes use a sphere-based coordinate system to project data onto a 3D spherical surface. Local scenes use a local coordinate system to project data onto a planar or flat surface. Global scenes are best for global or national scale data. Local scenes are best for local or city scale data. You should be able to explain how base elevation is used to display a GIS layer in 3D. Layers can be draped on the ground or a custom elevation surface. They can be floated relative to a ground or a custom elevation surface. Or Z-aware layers can be placed at an absolute height on the Z-axis. You should be able to explain how 3D display properties can enhance 3D visualization. Layer properties control how individual 3D layers are displayed within a scene, like elevation, extrusion, or lighting. Scene properties control how all 3D layers are displayed within a scene, like ground, coordinate system, and illumination. Last, in the lecture demonstration and in the project, you'll navigate a 3D scene in GIS.